And then this one's a little more complicated. So DEF. DEF. Okay.
You start to just think about it more. Like, kind of
we did a little of this today. I didn't really understand it. Anytime we see algebra, I just lose hope, but like, probably shouldn't do that.
You're gonna be fine. I get even more excited. I love geometry, but
yeah,
I love teaching algebra because of that exact thing. People lose hope with it.
Do you think more people like algebra or geometry?
I think the people who don't identify necessarily as being strong with math probably, on average, like geometry more.
Yeah.
Because it's more visual and real.
Exactly.
People who do identify with being good at math probably tend to like algebra more because it's more problem solving and like you can get super like theoretical with it and just go crazy with doing algebra to solve things that don't necessarily have to have a real life connection. So
yeah,
I like them both. Calculus is my favorite. Calc is super fun and like very real, very, very real. All right, so we got D, E, and then F over here, and then they give us angle measures, but they're not just like angle measures, they're like equations almost. X plus 30 degrees, 2x minus 45 degrees.
Oh,
which looks weird, right?
I should have wrote this a little differently. I need to write them next to each other to like show they're equal.
So all right, you're already getting there.
2x minus 45.
Okay.
So.
And they're equal, like, for the same reason, right?
Yeah, because parallel, congruent.
Sure. Okay. So now what? Now what? Now we're out of the realm of geometry.
Yeah. So now we need to. Do we start with getting rid of the x or getting rid of like the angles? Does it really matter?
Yeah, you could do either. My first step with an algebra problem like this is I typically ask myself, what am I looking for? What am I trying to solve for?
X.
X. Okay, so I'll come down here and write x equals.
Okay.
That's my end goal.
Okay.
So now how do I take this equation and slowly start to unravel it so that I end up with just an x on one side? You could do it from either side, but
yeah, we should start on this side.
Okay.
Get rid of 2, right?
So
or should we get rid of 45?
Yeah, we could do either. The harder way would probably be to divide everything by 2.
Yeah.
Because 45 doesn't divide evenly by 2. You can do it. 45 halves is a number. It's 22.5.
Okay.
If you don't want to divide because I can't just divide one chunk of my side by 2. Okay, if I'm going to do something, if I'm going to affect this side of the equation, I'm going to affect the whole thing, then I'm going to equally affect the other side. So what was your other option?
The other side?
We could do the other side, or what also could you do?
You could get rid of 45.
Cool. So I can just come in, I can add 45 to the whole side here.
Yeah.
And 2x minus 45 plus 45 is equal to what?
Wait, sorry, what was it?
What is 2x minus 45 plus 45?
But like, I thought you couldn't add, 2x minus 45, that's a negative 42 or 43?
I know what you're doing
44.
right now. Right, you're trying to mix
43.
You're trying to mix the x's with the terms that don't have an x in it.
Yeah.
And that's fine. That's like a very common thought.
Yeah.
Right? The reason they're written like this to begin with is because a term that's being multiplied by x is not what we call similar to a term that's not being multiplied by x.
Yeah.
You also can't add it to a term like this because it's also not similar. You don't have the same amount of variables. We can go on a longer tangent on this, but it seems like we're going to do it a couple times coming up here.
Yeah, because isn't this like more theoretical?
This is solving using symbols.
Yeah.
Right, so it's symbolic, which is kind of like theoretical in a sense.
Yeah.
But it's going to come out to give us real measures. So maybe I'll just kind of move us along on the first one since we have like 6 left and you'll be able to just keep practicing getting better. So you can add 45. Negative 45 plus 45 is equal to 0. Okay, and then 2x, if this makes you feel better, I could write it like this. How about we add 0x plus 45 to both sides?
0x plus 45?
Yeah, what's 2x plus 0x?
2x.
2x. And then what's negative 45 plus 45?
0.
0.
Yeah.
So do I really need to include the 0x?
You don't have to.
But does that kind of clarify? Yeah. If I do it to one side and I want to maintain this equality,
you have to do it to the other.
I have to do it to the other side, right? Balance that teeter-totter out, so I will add 0x plus 45 again.
5, 40, 50, so that's 75?
75 here. And then what's 1x plus 0x's?
That's 75. 1x plus 0x's is just x.
X. Cool.
So x.
So I'll just write this without the zeros.
Yeah. 2x equals x plus 75.
All right.
So now we get rid of the 2. Like divide 2x, right?
Yeah, we could get rid of the 2, and that would leave us with an x on this side, right?
Yeah.
And that's the goal.
Mm-hmm.
In our answer, though, do we want our answer to also include an x on the right side?
No.
So one way of kind of phrasing it, I like to say typically, is try to get anything with an x to one side and try to get anything without an x to the other side. Okay, so if we don't want to include the x on the right in our final equation, how can we move it to the left, or how can we cancel it out from the right?
So if we want to move 75, or move x.
We want to move this x over here.
Yeah.
In other terms, we want to cancel it out from this side. We don't want there to be an x anymore. There is one x.
Yeah.
So how do you get rid of one x if you already have one?
Minus x?
Yeah, you just minus an x. That's not bad, right?
Okay, but then you have to do it to that side?
You just have to do it to this side as well. And that's actually great because that's going to make our life easy here. What is x minus x on the right side?
X minus x is 0.
0.
So it's nothing, yeah.
Okay, and then plus the 75, right? I should do that in real pen, huh? So this is just 75. 0 plus 75. And then what's 2x minus x?
2.
If you have, give me something that could stand for x. Name an object that exists in the world.
A water bottle.
A water bottle. Okay, you have 2 water bottles. You get rid of 1 water bottle. How many water bottles do you have?
1x.
You have 1x left, right?
Okay.
And x is a thing.
Yeah.
We don't know what the thing is yet. So that's why it kind of stands in its own number space apart from a number like 45, which we know is exactly representative of 45 of whatever.
Okay.
But in this case, because we don't really know what x could be, it could take any number of inputs. That kind of comes back to why we're not combining here. We'll get more into polynomials in the future. I'm assuming they'll keep popping up. Why did I write this in 2 parts here? This was 1x equals 75. Or just x equals 75. So we got an answer.
So x equals 75. So 2 times 75.
Yeah, what's 2 times 75 up here?
2 times 75. What is 2 times 75?
Think of having 3 quarters, and then you now have 6 quarters.
6 quarters. $1.50.
150, right? 75 times 2 is 150.
Yeah.
So that's 150 minus 45. What's 150 minus 45?
150 minus 45. That's 105.
105 degrees.
And then that's congruent.
And you can just check what's 75 plus 30.
75 plus 30. 105.
75 plus 30 is, and that's to be expected, right?
Yeah.
And also, does that angle kind of look like 105?
Yeah.
Right. It's just a little more than 90.
Mm-hmm.
Okay.
I'll write it down.
Yeah, nice to check yourself at the end when you get an answer from an algebra problem, because it kind of brings it back together into the real world.
So x equals 75. And that means that D, E, F equals 105.
Cool. And that was our actual question, right? Not what
Yeah.
x was, but what the angle DEF was, and that was 105. Cool. And maybe next time we do a problem like this, maybe we'll guess what the angle will be at the beginning, just so that when we finally go through all the work and then we get an answer, we can be like, yeah, that seems right. Or like, whoa, I messed up, definitely.
Mm-hmm.